Opportunity was rolling across Mars when its cameras locked onto something that stopped the science team cold. A perfectly spherical object sitting on the surface that looked like it had been manufactured. It had not been manufactured. But what it actually was turned out to be evidence of a process that rewrote what we understood about Mars's watery past. Opportunity landed on Mars on January 25, 2004, 3 weeks after its twin Spirit touched down on the opposite side of the planet. Both rovers were designed for a 90-day mission. Opportunity operated for 5,111 Martian days, nearly 15 years, before a global dust storm in June 2018 covered its solar panels and ended communication permanently. NASA declared the mission complete on February 13, 2019. The discovery came early. Within weeks of landing at Eagle Crater, Opportunity's cameras photographed hundreds of small, gray, nearly perfectly spherical objects scattered across the Martian surface and embedded in the surrounding rock. They were a few millimeters in diameter, roughly the size of a blueberry, and their shape was so consistent and so regular that the team immediately knew they were looking at something chemically formed, not geologically random. The science team nicknamed them blueberries. Their formal identification required the rover's spectrometers and the rock abrasion tool, which ground into the surrounding bedrock to expose fresh material. The analysis confirmed what the team had hoped and suspected. The spherules are concretions of hematite, an iron oxide mineral that formed inside water-saturated rock. Here is how concretions form. Groundwater moves through porous rock, carrying dissolved minerals. When the chemistry changes, the pH, the oxidation state, the mineral concentration, those dissolved minerals precipitate out of solution and accumulate around a nucleus, growing outward in all directions equally. Because the growth happens spherically from a central point in a fluid medium, the result is a near-perfect sphere. On Earth, iron concretions of this type are found in Utah's Navajo sandstone, where they are called Moki marbles. The physical and chemical similarity to the Martian blueberries was striking and immediately useful as an analogy. The hematite in the blueberries was the real confirmation of ancient water. Hematite of this kind, crystalline, gray, in spherical concretions, forms in the presence of liquid water. It does not form through dry volcanic or impact processes. Its presence in large quantities, embedded in sulfate-rich sedimentary rock, painted a clear picture. This region of Mars was once soaked in liquid water. Groundwater was moving through the rock, and the chemistry of that water deposited iron minerals over time. What made the blueberries additionally strange was their surface distribution. After the surrounding softer rock eroded away, slowly, over millions or billions of years, the more durable hematite spherules remained, littering the surface in their thousands. Opportunity was driving across the floor of an ancient Martian geological history book, and the blueberries were footnotes written in iron. Later in the mission, Opportunity encountered something even stranger, a blueberry variant. At a location called Kirkwood near Cape York, on the rim of Endeavour Crater, the rover photographed spherules that were different from the original blueberries, larger, with a different texture, arranged in clusters. These were nicknamed newberries, and their composition and formation mechanism differed enough that scientists concluded they formed through a different process, possibly involving later water chemistry or a different mineral source. The existence of two distinct spheral populations in the same region complicated and enriched the water history story. The blueberries were not the only strange objects Opportunity encountered. The rover photographed Mars's first meteorite, a basketball-sized iron-nickel rock named Heat Shield Rock in 2005, found near the debris of Opportunity's own heat shield. Subsequent meteorites were found throughout the mission. Mars's thin atmosphere means meteorites reach the surface more intact than they would on Earth, and the dry, oxidizing surface preserves iron meteorites for extraordinary lengths of time. What the strangest objects on Mars have in common is that each one is a record of a specific moment in geological or astronomical history. Blueberries from ancient groundwater chemistry, meteorites from space, each sitting exactly where physics and chemistry placed them. Follow for more on what Mars's most unexpected discoveries are telling us. And tell me, of all the strange objects Opportunity found on Mars, the blueberries, the meteorites, the newberries, Which one do you think carries the most important scientific information about Mars's past?